Okay, let's look at one more where we're doing the definite integral of e to the x times sine of x dx. Sorry, the indefinite integral here. And I'm not sure which one to do, but let's try a equals e to the x and db equals sine of x. So b is equal to negative cosine of x, and dA is equal to e to the x. So I'm going to take this and do my a times b, which will be e to the x times negative cosine of x minus definite integral of dab. So again, this is e to the x times negative cosine of x. And so this is negative e to the x cosine of x minus, and I'm going to take this minus minus and make it be plus, definite integral of e to the x cosine of x dx. Now, is e to the x cosine of x dx really simpler than e to the x sine of x? I would say probably not, but let's just keep going and see what happens. So I'm going to use IBP again. And when I do that, let's have this out. I'm going to say, okay, here's my side calc for my second IBP. Calc for the second IBP will be about the indefinite integral of e to the x cosine of x dx. So I'm going to say a is equal to e to the x, and dA is equal to e to the x, and dB is equal to cosine of x. So b is equal to sine of x. And when I plug this in, I get e to the x times sine of x minus the integral of e to the x sine of x dx. Okay. So I figured out that this integral is equal to this whole thing. So I'm going to carry that over now. I'm going to say that what I figured out, I replaced this calculation and continue on, is that now what I have, e to the x sine of x dx is equal to negative e to the x cosine of x plus e to the x sine of x minus the indefinite integral of e to the x sine of x dx. Now you may be looking at this and thinking, wow, what a disaster. The same thing here, I have the same integral on both sides. But that's actually good. I can just treat this like an unknown. It's like if I had a equals b plus c minus a. Just add a to both sides and solve for it. So this algebraic pattern works even if my unknown is a whole integral. I'm just going to add this integral to both sides. I think this trick is so slick, I'm so excited to get to share it with you. Okay, so these cancel. Now I've got two of these, so this becomes 2 times the indefinite integral of e to the x sine of x dx is equal to negative e to the x cosine of x plus e to the sine of x. And all I have to do to solve is divide by 2. So if I multiply both sides by 1/2 here, I get the indefinite integral of e to the x times sine of x dx is equal to 1/2 times negative e to the x cosine of x plus e to the x sine of x. And let me add on a plus c here. But that's all. So what happened is I started taking integration by parts. And when I got to there, I did another integral that involved integration by parts. And that integral involved the same integral as the first thing. That was actually good. That made it easy to simplify because I saw the same thing on both sides, so I could solve for it algebraically.